Let's go ahead and perform this operation, which is division. That's our division line right there. And to do this, I'm going to do it in two separate parts. So I focus first on the decimal. So I've got 2.64, 2 and 64 hundredths divided by 5 and 5 tenths. Now I just put this in the calculator with the division button, and it gives me this 0.48, and that's 48 hundredths. All right, now I'm going to leave that there, and then we're going to focus on our base 10. So on the base 10s, I've got 10 to the power of 3 divided by 10 to the power of negative 15. Using our exponent rules, we have the same base, 10, so I'm going to take the numerator exponent of 3, and since we're dividing, in this case, we're going to subtract the denominator exponent of negative 15. Now notice, that's minus negative 15, so really it's going to be an addition of 3 and 15, which is going to make 10 to the power of 18. All I need to do now is take these two and combine them, and then I'm going to have to do something else. So I'm going to do multiplication. I'll just do it as a dot right there. But I've got 48 hundredths times 10 to the power of 18. What we don't want is a 0 in the ones place value. We don't want any tens, hundreds, or anything to the left of the ones place value either, which means that I really need the decimal in between the 4 and 8. It should look something like this, 4.8. Now we're still going to multiply by a base 10, but by moving the decimal to the right, making this number bigger, that means that I had to use it from my base 10 to the power of 18. And since I made that one bigger, the exponent must be made smaller. So it's going to be 10 to the power of 18 minus 1, which is going to give me a power of 17. And this right here would be my final answer because, again, I must have a non-zero number in my ones place value if the answer must be written in scientific notation, which this does. Now, something else you could do is on the calculators that we use, you could just use the N over D button, right? You could say N over D, and then you could type in 2.64. Now, that would show in the fraction as 2.64. This is what you should see. To multiply this by 10 to the power of 3, there's a quick way to do it. Of course, you could just multiply it by 10 to the power of 3 with several button strokes. But it's 3 buttons above 8. You're going to see this button right here, times 10 to the power of n. And when you push that, so 2.64, if I push that button, you're now seeing the fraction is going to extend, and it's going to be multiplied. Well, I guess it's an x there, multiplied by 10. And then the cursor is waiting for you to put in that exponent. Well, the exponent we know from the original problem was a 3. So you just type in 3. Now to get out of that, you got to push over and then down, which is going to send you to the denominator. Then you just type in 5.5. And then again, I would just push that 10 to the power of n button. So times 10 to the power of n. And that exponent was negative 15. Enter. And that would show exactly this scientific notation problem on your calculator, and it did simplify this for me also as 4.8 times 10 to the power of 17. So that's what I would recommend doing, at least to check. Of course, we want you to know how to do the work, but the calculator knows how to do it as well, and calculators are great tools to use, so use them.